Good afternoon, children. Good afternoon, online children.
Good afternoon, ma'am.
Good afternoon. So in today's class, we learn how to construct histograms and frequency polygons. So this is of the chapter statistics. All right. So first we'll learn about histograms. A histogram is a graphical representation of a grouped frequency distribution. A histogram is a graphical representation of a grouped frequency distribution. So you have a frequency table, a frequency distribution table, which has two columns, class intervals and frequencies. Okay. So when you have a table with these two columns, class intervals and frequencies, this distribution is called a frequency distribution because it shows frequencies corresponding to some data. And the first column is a class intervals, right? You understand what class intervals are. So it specifies a range. So when I say 100 to 200, it's a class interval where 100 is the lower class limit and 200 is the upper class limit, right? 100 to 200. So here 0 to 10. 0 is the lower class limit and 10 is the upper class limit of the class interval 0 to 10. Of the class interval 0 to 10. Now, when you take this class interval 10 to 20, 10 is the lower class limit. 20 is the upper class limit. And these are called class intervals. Class intervals. All right. So what you see here is a frequency distribution. The first column showing the class intervals and the second column showing the corresponding frequencies. Now, when you try to represent this graphically, that graphical representation is called a histogram. If the class intervals, see, grouped frequency distribution are of two types. Grouped frequency distributions are of two types, where the class intervals are continuous, where the class intervals are not continuous. When do you call a frequency distribution grouped? When you have class intervals. If the table has class intervals, it is a grouped frequency distribution. That's all. I can see class intervals, grouped frequency distribution. But the class intervals can be of two types. The class intervals may be continuous or not continuous. If they are not continuous, you have to make them continuous and then put up the histogram. Now, here the class intervals are continuous because see, I can read it like 0. How does it read? 0 to 10, 10 to 20. The next class interval picks up from where the earlier one stopped. 0 to 10. 10 to 20, 20 to 30, 30 to 40, 40 to 50. So here the class intervals are continuous. There is no break. But if it was 1 to 10, 11 to 20, 21 to 30, 31 to 40. So there's a gap, no? Between 10 and 11, we know there are infinitely many numbers between 10 and 11. So a number like 10.5 is not included in the class intervals here. So supposing you have a value 10.5, you cannot include it in this class interval because this holds values only from 1 to 10. 1 to 10 meaning values 1 to 10. 11 to 20 values 11 to 20. Then what about 10.5? Okay, so here the class intervals are not continuous. You can make a histogram for this, but you'll have to make the class intervals continuous and then make the histogram. So once again, you can see class intervals So you call this frequency distribution a grouped frequency distribution because you can see class intervals. Class intervals can be of two types. Continuous class intervals not continuous. If they are continuous, the table is ready to prepare a histogram. If the class intervals are not continuous, it's not ready. You need to make the class intervals continuous and then put up the histogram. Okay. So you can see a frequency table here, and you can see a grouped frequency distribution here, wherein the class intervals are continuous. So you can just put up the histogram. No extra column needed, nothing. Just with the data given, you can make the histogram. All right. So you have to show the class intervals along the x-axis and the frequencies along the y-axis. All right. Now, see the range of the frequencies. The smallest value is 2 and the largest value is 22. So what's the range? The range is the smallest value is 2, the largest value is 22. So range is the maximum value minus the minimum value. Range of the data. Like when you go shopping also, nowadays we don't ask, we just pick whatever we like. But in my days when we used to go shopping for Diwali, the range was fixed. We had to pick in a certain range. So if I had to pick a chudidar, then it should be like between 500 to 1000 or some limit like that. I can't pick whichever I like. I should like whatever is in that range. So if my family is fixed 500 to 1000 rupees, then I have to pick which I have to like a chudidar which is in that range. Yeah, but now shopping has changed. We pick what we like and then we see the price and pay and keep coming. Sometimes we don't even see that till the, at the cash counter they tell us. Okay. So the range is the maximum value minus the minimum value. 22 minus 2, which is 20. Okay, that's just an information. Range is maximum value minus minimum value. So 22 minus 220. That's the range. Now, why should we look for the range here? Why should you look for the maximum and minimum value? Because only those numbers tell you how to decide, the values along the y-axis. How do you consider the values along the y-axis? Should I mark 10, 20, 30, 40? Or should I mark 1, 2, 3, 4, 5? Should I mark 5, 10, 15, 20, 25? How should I mark 20, 40, 60, 80? Or 100, 200, 300, 400? How to decide? Okay, see, along the x-axis, no decision. Okay, along the x-axis, there's nothing to decide because see here, can you see the 7? Can you see the 7? All those numbers are what you'll have to show along the x-axis. These numbers you'll have to show along the x-axis. Here, this 7. All these numbers. 0, 10, 20, 30, 40 till 80. 0, 10, 20, 30, 40, 50, 60, 70, 80. Am I clear? So along the x-axis, we have nothing to decide. It's given in the data itself. Y-axis, we need to decide how to mark off the values. All right. How to mark off the, how to mark off, meaning what value to assign for this marking, what value to assign to this marking, what value to this marking, and so on. So the smallest value is 22, the highest value is 22. The highest value is 22, the smallest value is 2. Okay, so now we'll have to think 2, 22. Supposing I mark 10 here and 20 here and 30 here. What's the maximum height of my rectangle? 22, because that's the highest frequency. So my tallest rectangle will be 22 units high. Okay, so 22 meaning I'm just showing you so somewhere here. Your tallest rectangle will be of this height. And the others will be shorter than that. Yes or no? Don't you think that will be too small a histogram like you have if your graph is like this and your tallest one is here like this, the others are like this. It looks like a miniature histogram of so small. So you're not supposed to make a small one like this also. At the same time, your rectangle should not be very large, like, the whole page, your long size book, that full page, one tall rectangle like that. So it should be very rational. So what is small, what is big is your eyes can decide that. No, this is too small. Oh, that's too, like very lengthy rectangle. That you can decide. So you have to decide using these values, the maximum and the minimum value, the markings on the y-axis. So here we have taken 4, 8, 12, 16 because here, 12, here, multiples of 4. So you can even take 2, 4, 6, 8, 10. So it's not fixed. You can mark off 2 here, 2, 4, 6, 8, 10, 12. Till where will you mark? Till 24. You need till 22. Just take one extra, 24. Okay. But 10, 20 will be like too small because 22 is somewhere here. 10, 20 and 22 is somewhere here. So that will be your tallest rectangle. No, that will be too, meaning the rectangle will be too small. So you should not take 10, 20 here. Okay. So you can even take 2, 4, 6, 8, 10. But till where should you mark? 24. That's it. 26, 28, you don't have to show because you don't have any frequency beyond 22. So you can stop at 22, but we'll just take one more, 24. Is that fine? Okay. So now how to draw the histogram? 0 to 10, the height of the rectangle is 4. 0 to 10, the height of the rectangle is 4. See, this is 0. The class interval is 0 to 10, and the height of the rectangle is 4. The frequency represents the height of the rectangle. Then 10 to 20, the height of the rectangle is 10. 10 to 20, 10 to 20, the height of the rectangle is 10. And where is 10? Between 8 and 12. Because see, between 0 and 4, this is 2. Between these two, this is 6. This is 10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, this is then how much should this be? 24. There's a mistake, printing mistake. Okay. So this is 22 and 24. All right. Okay. Then next 20 to 30, the height of the rectangle is 16. 20 to 30, the height of the rectangle is 16. Can you see here 16? Then 30 to 40, the height of the rectangle is 22. 30 to 40, the height of the rectangle is 22. And so on, children. All right. So in this frequency distribution, the class intervals are continuous. So you can straight away put up the histogram. What values to show along the x-axis? All these values. Along the y-axis, you need to decide the scale. It's called a scale. You need to decide the scale along the y-axis. That is done using the highest value and the lowest value. Okay. So in this case, you can even mark off 2, 4, 6, 8, 10 along the y-axis, or like what you see here, 4, 8, 12, 15. So this is the class interval 0 to 10 with the frequency 4. This is the class interval 10 to 20 with frequency 10, and so on. All right. What is the difference between the earlier table and this table? So here you can see the class intervals. The first class interval is 50 to 55. Okay, so the values you'll have to show along the x-axis are 50, 55, 60, 65, 70, 75. Correct? These values. So 50, 55, 60, 65, 70, 75, 80, and so on. So there is a jump, right? Now, where do the x and y axis meet? At 0. Okay, now from 0 to 50, you don't need any values because your class interval, the first class interval is 50 to 55. You don't need the class interval 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50. You don't need all this. Starts off only from 50 to 55. So you don't have to unnecessarily show all that, like 5, 10, 15, 20. You don't have to show all those values unnecessarily. But at the same time, you're jumping from 0 to 50. So this is called a kink. Kink. Or a broken line. A broken line. When do you use that? When, there is a leap from 0 to the first value. It's not continuous. No, from 0, we're jumping to 50. From there on, it is smooth. 55, 60, 65, 70, 75. So it's actually jumping in fives. But initially, you make a big leap. You jump from 0 to 50. And from there on, like equal jumps, 55, 60, you're jumping in fives. But initially, you took a big jump, right, from 0 to 50. So you need to show that broken line. So like this, nothing, it's, you don't have to copy this line exactly. You can just like, see, like, you can just go up like this and, or you can, sometimes like this, anything like this. Just show that broken, just so show that zigzag. There's a y-axis, x-axis. And then here, anywhere close, you can just mark 50, 55. So some 1 centimeter to 2 centimeters you'll waste in the front. So that like this one, you can just use this for the broken, to show the broken line. And you can start marking from here 50, 50, 55. Okay. You can also show it like this and mark 50 here and 55 here. Just leave this gap. That one is reserved for the zigzag broken line. Okay. That's it. The rest is the same. Then see the values 3, 6. This is the second question. See the frequencies. The highest values 12. Online children, again, I forgot to ask you. I've shared my screen. Visible, right? All of you?
Yes, ma'am.
Okay. I'm audible.
Yes, ma'am.
Thank you. The highest value is 12 and the lowest value is 3. So will you take a scale of 10 on the y-axis? 10, 20, 30, 40? No. The highest value is 12. 10, 20, 30, 40. 20, 30 is not needed. The highest value is 12. So you can even mark 1, 2, 3, 4, 5 or 2, 4, 6, 8, 10 along the y-axis. 1, 2, 3, 4, 5 is also good. Or 2, 4, 6, 8, 10. This one these images I've just snipped from the books, okay? So here you see a 2, 4, 6, 8, 10. This is good. 2, 4, 6, 8, 10 is good. Or even 1, 2, 3, 4, 5. Because 12, not very tall. It should be half your graph book, it will take up only half the page of your graph book. So that's fine. So the only difference between the first one and the second one is that of the kink, the broken line. The rest is the same. 50 to 55, the height of the rectangle is 12. 55 to 60, the height of the rectangle is 8. And you see in the histogram, the rectangles should stick to one another. There is no gap between the rectangles. When there is gap, that's a bar graph. When there is gap, it's a bar graph. Okay, no gap, histogram. This one, again, is a different type of a frequency distribution, wherein the class intervals are continuous, but they don't have the same width. So see the different types. That's what I have in my first slide here, but I didn't want to read it without explaining. I'll explain all the types and then show you this. It'll be more meaningful. You can understand better. I thought I'll read it for you, and then I quickly started with the first one. So sometimes it's like, she's just jumping into the topic without giving any introduction. Sometimes introduction will be so lengthy, you will not be able to comprehend much. So it's better I explain and then come back and talk about this. I think I can reach you better. Okay. See this one. So the first one, class intervals continuous, uniform width. The width is 10. 0 to 10, 10 to 20, the width is 10. Second table, continuous class intervals, 50 to 55, 55 to 60, continuous. Width also is 5. It's the same everywhere. But the only difference is this one, right? Okay. In this one, continuous. Okay, it starts from 10, 10 to 15. Okay, that's fine. Fine. Class intervals are continuous, but they don't have the same width. Can we see that? 10 to 15, 5 is a width. 15 to 20, 5 is a width. 20 to 25, 5. 25 to 35. 30 to 40, 10. 40 to 60, 20. 60 to 80, 20. The width is not uniform. The width is not uniform. So when the class intervals behave like this, you cannot, the table is not ready to prepare a histogram. You need to make changes with the frequency before you make the histogram. Class intervals you cannot change. Frequencies will change. Frequencies will change. Class intervals you cannot change. So we'll have to alter the frequencies. So now this frequency distribution is not ready. You cannot put up a histogram using this table. Why? Because the width is not the same everywhere. Some class intervals have width 5, some have 10, a few have 20, one has 10, 4 has 5, 2 have 20. So the width is not the same. So what do we do? So this is the formula. How do you find the adjusted frequency? Okay, the adjusted frequency is so you can call it by different names. Sometimes it's written like this. Some schools are like this: width of the class, height of the class. I'll show you both. So you can just use. See, at the end of the day, the way it is worked and the graph is going to be the same, but the presentation of the frequency table may vary from teacher to teacher. So I have both of it. So you can just write this adjusted frequency is equal to desired class size by actual class size into frequency. Desired class size. What is that uniformity in class size you want? The class size or the class width is different. It's 5, it's 10, it's 20. So what is your desired class size? Class size is the class width. There is 5, there is 10, there is 20. Which one do you want? So you always go for the smallest, which is 5. It is 5. You always go for the smallest, which is 5. Sitting at 1. Okay. So 1 minute. Thank you, children. So the need to find adjusted frequencies is because the class intervals have different sizes. All right, so this is the formula. Desired class size by actual class size into frequency. Now, desired class, so what are the different class sizes we have? 5, 10, and 20, which is the smallest 5. So that is the desired class size. Okay, so now let's use the formula. So I've written these, this is the answer. This is the question. This is the answer. You can see these class intervals as it is here. No change, as it is here. All right. The second column also, frequency, same values here. But we are not going to use these values to make the rectangles. Okay, these values will not be used to make the rectangles. We're going to find new values in this column called adjusted frequency using this formula. Okay, so see here. So the different sizes are 5, 10, and 20. Desired is 5. So you can see the desired formula. Okay, desired class size 5. By the actual size, what's the actual size? 5 only. So the frequency will not change, but still you'll have to show the working. Frequency will not change if the desired class size and the desired is what you want and the actual size, if both are the same, why will the frequency change? The frequency will change only when the desired class size is different from the actual class size. Only then the frequency will change. You see here? Here also, what's the class size? 5. Desired 5. So same answer you will get. So desired class size 5 by actual class size 5 into the frequency 9. So same answer. 5 and 5 get cancelled, 9. Same thing you'll get. So I'll show for this one. Let's look at 30 to 40. So 30 to 40. What is the class size? 10. What is it? So what is the actual class size? 10. What is the desired class size? 5. So see here. Desired class size by the actual class size into the frequency. So when you work this, 5 ones are 5 twos are. So 12 by 2, 6 is the adjusted frequency. Now for this one, what is the size? 20. Class size is 20 because 60 minus 40 is 20. 60 minus 40 is 20. The class size is 20. Okay. But what is the class size you want? 5. Desired class size 5 by the actual class size 20 into the frequency 12. So when you cancel 5 ones are 5 fours are 12 by 4 is 3. So like this, we'll have to find new frequencies. Okay, or the adjusted frequencies. That's all. Now use these class intervals and their corresponding adjusted frequencies and put up the histogram. Now, this is from a book, so now don't ask me like why is so much gap here. Ignore that, okay? So it's like this. This is 0, right? Now, what are the values you need to show here? All these values. Correct? You don't have to show the kink because 0, 10. You don't have to show the kink. So see here. This is 10, okay? This is 20. Between that will be 15. See, when you're marking every 10 divisions, you're going to mark 10. Listen to this carefully. These are the numbers that you'll have to show along the one. I'll use the questions, right? One. Okay, so these are the numbers that have to be shown along the x-axis. 10. Let me show the main markings, okay? These are the main markings. Okay, 10. So I have to mark 20 only here. I have to mark 30 here. Just because it's 15, I cannot write 15 there. Every 10 divisions, I'll have to mark 10, 20, 30. So this is 40. This is 50. This is 60. This is 70. And this is 80. And this is 90. Okay. But we need other values also. You can see here. We need other values. We need 15. So go between 10 and 20 and mark 15. Then we want 25. So go between 20 and 30 and mark 25. That's it. Okay. And there are some numbers which we don't need also. We don't need like 50. See, you see a 40 couple, we have only 60. We don't need 50. I haven't finished actually. Are you getting me? So far. Now, what are the numbers you need? 10, 15, 20. See, you need, erase what you don't need. 10, 15. 10, 15 you need. 20 you need. 25 you need. 30 you need. 40. Then you don't need 50. Erase it. But it's there. 50 is there, but you're just erasing it because you don't need it. You don't have to erase it also. It's not that you should erase it. But what you should not do is don't mark 50. After 40, don't mark 60 here. That's wrong. Mark correctly. Remove the numbers which you don't want. See, that part I'll repeat so that I make sure all of you understand that clearly. See, 10. After 10 divisions, 20. After 10 divisions, 30, 40, 50, 60, 70, 80. These are we mark. But when you look at the numbers here in the class intervals, we have 10, 15. 15 is not there. So what you should do, go and mark 15 because you want 15, right? You mark 15. Then 20 is there. 25 is not there. So you mark 25. Then 30, 40. It's there, 30, 40. Then 60, 50 is not there. So you can just erase it. Anyways, you're going to mark it with a pencil. You can erase 50. Then after that, 60 and then 80. Okay. So what is not needed? 70 is not needed. You can erase it. 90 is not needed. Okay. Okay. This is how it should be. 40 to 60 na இவ்ளோ gap இருக்கணும். 10 to 15 na இது கம்மியா தான் இருக்கும் gap. நீங்க வந்து இப்படி 10 அடுத்த 10 divisions 15 அடுத்த 10 divisionsல 20 அப்படி போடக்கூடாது. That's wrong. இங்க 10 அடுத்த 10 divisionsக்கு அப்புறம் 15. That's wrong. Then அடுத்த 10 divisionsக்கு அப்புறம் 20 and then 25 then 30. You should not write these numbers as you see on the x-axis. You get the difference? Now make the rectangles. Now make the rectangles. 10 to 15, the height is 7. Okay. So along the y-axis, I think 1, 2, 3, 4 till 12. Okay. So 1, 2, there's no space, so I'll just squeeze it like this. 5, till there's no place. Okay, excuse me. So now 7. 10 to 15 is 7. 10 to 15 is 7. 10 to 15 7. So 10 to 15. You start on 10 and land on 15. You start at 10, you rise up to 7, and then you come down to 15. Then 15 to 20 is 9. 15 to 20, you rise up, 15 to 20 is 9. 9. And then you land on 20. That is 15 to 20. 20 to 25, 8. So this is 8, no? 20 to 25. 20 to 25. So it should land on 25. 25 to 30 is 5. 5. 25 to 30 is 5. So like this. Then, I'm sorry. We have to use the adjacent frequencies. Now, in the question table, I start. Okay, we have to use the adjacent frequencies, not these frequencies. Sorry, I was in the question slide, so just make that mistake. Fine. What I was trying to tell you is how to mark the numbers along the x-axis. And then along the y-axis, as I told you, 1, 2, 3, 4 till 12. And then, yes, I told you how to start and land. Use the class interval. Okay. So 10 to 15, the height is 7. The height is 7. 10 to 15, the height is 7. So see here, 7. Then 15 to 20, use the new frequencies. 15 to 20, the height is 9. 15 to 20, the height is 9. 20 to 25, the height is 8. 20 to 25, the height is 8. And so on. So you can see the last one, 60 to 80, the height is 2. 60 to 80, 60 to 80, the height is 2. The height is 2. Okay, 60 to 80 meaning 60 to 80. The height is 2. The frequency is 2. So when the class size is not the same everywhere, you'll have to prepare one additional column called the adjusted frequency column. And the frequencies here are calculated using this formula. Desired class size in divided by actual class size into frequency. The class size is 5, 5, 5, 5, 10, 20, 20. So the smallest value is the desired class size. The actual class size is what actually it is into the frequency. That formula will help you calculate these frequencies. What's the class size here? 0 to 10? 10. 10 to 30? 20. 30 to 45? 15. 45 to 50? 50 to 60? 10. Are the class intervals continuous? No. They are continuous, no. See, the next class interval picks up from where the earlier one stopped, 0 to 10, 10 to 30. There's no gap. 30 to 45, 45 to 50, 50 to 60. The class intervals are continuous. There is no gap. The class intervals are continuous, but they have different sizes. The class width is not the same everywhere. They are continuous. The width is not the same everywhere. So in a table like this, we'll have to create that extra column called the adjusted frequency column. Go through this. The class sizes 10, 20, 15, 5, 10. So these are the different sizes available, and you have to pick the smallest size, 5. 5. So you can see here, desired class size 5 by the actual 10 into the frequency 8. This is the new frequency. For the next one, the desired class size is 5. The smallest is 5. By the actual size, what's the actual size? 20 into the frequency 32. All right? Okay. So here, these are the numbers you should show along the x-axis. 0, 10. There is 20 here. There is 20. It's not shown because you don't need it. 30. There is 40 here. And between 40 and 50, this is just 45. Usually mark பண்ணதான் பண்ணுவேன். So நான் என்ன சொல்லுவேன், you mark 10, 20, 30, 40, 50, you mark all this. Then you come between them. You need 45, right? 45 here. Then you need, that's all. So you erase the ones you don't need. You erase the ones you don't need. 60. What you don't need? 10. This 20 is not needed because 10 to 30, 10 to 30, then 30 to 45, 30 to 45, 45 to 50, 50 to 60. All right. And the answer to the question, is it mandatory to erase? No. It's not compulsory to erase. You can have the numbers. It's not mandatory to erase. But at the same time, it looks better like this. Contradictory answers. It's not mandatory. You don't have to erase. At the same time, when you show on the numbers that are just needed, it looks better. Because it's easy to read now. 0 to 10, the frequency is 4. 10 to 30, the frequency is 8. That's about adjusted frequencies. Now here, this is another type of frequency distribution wherein you have the midpoints or the class marks. Class mark is called the midpoint or the mid value of a class interval. So what you see here are the class marks, which are the mid values of the class interval. So the class interval is not known. What to what you don't know. But the class mark, the mid value of the class interval is 150. This one. You don't know the lower limit, you don't know the upper limit. But the mid value of that class interval is 160. No, but to put up the histogram, we need the class intervals. To put up the histogram, we need class intervals. With this, we cannot make the histogram. So what you have to do is, what is the difference between any two consecutive midpoints? 10. 10. Divide by 2. 5. Now, add 5, or say we'll start with -5. Subtract 5 from all these numbers. You will get the lower limits. Add 5 to all these numbers, you'll get the upper limits. I'll repeat. Find the difference between any two consecutive class marks. 160 minus 150, 10. Divide by 2, 5. Now, to these values, subtract 5. You will get all the lower limits. To the same values here, add 5. You will get all the upper limits. So what is 150? What is 150 minus 5? 150 is the first one. What is 150 minus 5? 145. What is 150 plus 5? 155. 145 to 155. This is the midpoint of the first class interval. Subtract 5, 145. That's the lower limit. Add 5, 155. That's the upper limit. Take the next mid value, 160. Subtract 5, 155. That's the lower limit. To that mid value, add 5. Upper limit. Am I clear? Supposing the difference is 20, okay? So like 100, 120, 140, 160, 180, the difference is 20. By 2, always by 2, 10. 20 by 2 is 10. So to these midpoints, subtract 10 to get the lower limits. To the same midpoints, add 10 to get the upper limits. You can see for this one, 180 minus 5, 175 is the lower limit. 180 plus 5, 185 is the upper limit. And the frequency is 12. So this is the other type where the class intervals are not given. Instead, we are given the class marks or the mid values of the class intervals. So using the mid values, you need to construct the class intervals. You need to find the class intervals and then put up the histogram. Now this table is ready because the class size is the same everywhere. It's 10 everywhere. But you can see from 0 to the first value is 145. There's a big jump. To jump from 0 to 145. So the kink. So that kink. Can you see the kink? Yeah. So that first 10 units, you can just show the kink like this. And then this one is 145. This one is 155. 165 and so on. These values you should show along the x-axis. 145, 155, 165, 175. These numbers you should show along the x-axis. Why kink? Because you're jumping from 0 to 145. So the kink. And from 145, it is 155, 165, 175, still 205. That's about the numbers on the x-axis. Y-axis, see the frequencies. Look at the frequencies. So 2, 4, 6, 8, 10, or what you see here, 4, 8. You can even take 5, 10, 15, 20. All right. Now, what's more important is how to identify. When you take, now in the scale along the y-axis, which marking is 25? The marking after 24 is not 25. Which marking is 25? The marking after 24 is not 25. That is only when the scale is 10. When the scale is 10, 0, 10, 20, 30, 40, then every marking, we count in one, we jump counting in one. So like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every marking is like plus 1, plus 1. Now when scale is 4, so supposing this is 16 and this is 20. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is that marking 16, and this is the next one, 20. I've just magnified it. Okay. So after 16, you will see all these subdivisions before you reach 20. Now, how do we read? What is the value assigned to every subdivision is what we're trying to understand now, which is very important. In this graph, the scale along the y-axis is 1 centimeter is equal to 4 units. Okay, in this graph, the scale along the y-axis is 1 centimeter is equal to 4 units. Now, how do we read the subdivisions? What is the value associated with every subdivision? Is what we're trying to understand. So we'll just take this part from 16 to 20. You will have so many, you can count. These are the subdivisions you will find between 16 and 20. What is the difference? But the scale is 4, right? Divide by 10 always, because the divisions are like that. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 divisions. You always divide by 10. What's the scale? 4 by 10. Your scale by 10, always by 10. Your scale is 4. 1 centimeter is 4 units. So 4 by 10, 0.4. We'll have to skip count in 0.4. We'll have to skip count in 0.4, 16, 16.4, 16.8. This division is 16.4, not 17. 16.8, 17.2, 17.6, 18. This is 18. Correct, no? 16, 20, the value in the middle is 18. 18.4, 18.8, 19.2, 19.6, 20. This is how you read the subdivisions. After 16 is not 17. So the value associated with every subdivision is different when you change the scale. After 16 is 17, when the scale is 10. If the scale is not 10, it's not like that. The subdivisions will have different values. Now, supposing the scale is, we'll say 20, 40, 60, 80. Okay, so we'll say 20. 1, 2, 3, 4. Okay, 20, this is 40. So along the y-axis, 1 centimeter is equal to 20 units. So we have marked 0, 20, 40, 60, 80, 100, 120, and so on. So the scale is y-axis 1 centimeter is equal to 20 units. 20 by 10, always by 10. 2. So we'll have to skip counting 2s. 20. This one is 22, 24, 26, 28, 30. 32, 34, 36, 38, 40. So if you have to mark 35, 35, this is 30, 32, 34, this is 36. So 35 is between that. You cannot find an exact position. It will be between those two lines. Because you can find 32 exactly, 34 exactly. Or 35 is sorry, you can find, what did I say, 35, right? So it'll be between 34 and 36. I'm not able to recall what I said. This is 30, 32, 34, 36. So between 34 and 36 is 35. So this is how we read. So you should be careful about that. So in this case, 25, no? 25. This is 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 28. Okay, this 24, 28. We know 25 is somewhere here. But this is not 25. This is not 25. Then which is 25? I'm talking about this scale, 4. 4 by 10, 0.4. 4 by 10, 0.4. 24, 24.4, 24.8, 25.2. This is 25.2. 25.6. Then 6. No, 1 second. I'll just come again. 24, 24.4, 24.8, 25.2, 25.6, 26. 25.6 plus 0.4, 26. This is 26. 26.4, 26.8, 27.2, 27.6, 28. So there's no 25 here. So 25.2. This marking, between these two, you should show 25. The 25 is not easy to mark in there. Count பண்ணோம் இது 25 இது 24 இது 24.4 இது 24.8 இது வந்து 25.2 ஆனா 25 வேணும். ஸோ இது ரெண்டுத்துக்கு நடுவுல போடணும். பென்சில் டிப் வந்து இவ்வளோ நல்ல பட்டையா இருந்ததுன்னா கரெக்டா காமிக்க முடியாது. ஸோ யூ ஷுட் யூஸ் your pencil tip should be fine so that you are able to, show it accurately. All right. And this is the last 5 where the class intervals are not continuous. See, it's not continuous. We'll read 10 to 14. It's not picking up from 14. 15 to 19. It should pick up from 19. No. 20 to 24. 25 to 29, 30 to 34. So clearly the class intervals are not continuous. The class intervals are not continuous. This is the first question where we are coming across a frequency distribution where the class intervals are not continuous. This is the first question. In all the earlier questions, we had some, different type of distribution, but everywhere the class intervals were continuous. The class intervals were continuous. So they had different sizes. All right. They had different, the class width was not uniform. Or maybe we were not given the class intervals itself. We had the mid values. So this is a question where the class intervals are not continuous. So you just have to make the class intervals continuous and make the histogram. So to make the class intervals continuous, 15 minus 14, 1, divide by 2, 0.5. Subtract 0.5 from all the lower limits, add 0.5 to all the upper limits. How did we get that value 0.5? 15 minus 14. Or you can do 30 minus 29. 30 minus 29. 1 by 2, 0.5. The difference can be 2 also. It should be 1. It can be 2. The difference can be anything. But you should always divide by 2. So 1 by 2 is 0.5. So 10 minus 0.5. 9.5. 14 plus 0.5. 14.5. So the class interval for the first one will be 10 minus 0.5, 9.5 to 14 plus 0.5, 14.5. For the second one, subtract 0.5, add 0.5. So 14.5, because 15 minus 0.5 is 14.5 to 19.5. Subtract 0.5, add 0.5. So it will be 19.5 to 24.5. Subtract 0.5, add 0.5. 25 minus 0.5, 24.5 to 29.5. Subtract 0.5, add 0.5. So 29.5 to 34.5. So here we have the class intervals continuous. 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5, and so on. So this is how we make the class intervals continuous. Write the same frequencies. So when the class intervals are not continuous, make them continuous, write the same frequencies, and put up the histogram. And what values to be shown along the x-axis? These values. All these values must be shown along the x-axis. So there should be 9.5, 14.5. So this has a uniform jump. Like from 9.5 to 14.5, 14.5 to 19.5, the jump is uniform. So you can, that 10 centimeter marking, no? That main marking, you can show 9.5. The next one is 14.5. The next one is 19.5. Next one, 24.5. These numbers you must show along the x-axis. At every main marking, the dark green line, you can show 9.5, 14.5, and so on. 1 second. Okay. And the kings you understand. And look at the frequencies here, 300, 980, 800, 580, 290. So here the scale is 200. Along the y-axis, 1 centimeter is equal to 200 units. You can even take 100, 100, 200, 300. So when you mark off in hundreds, okay. Okay, now let's discuss 200 first. 200. So say this is 400 and this is 600. Okay, 400, 600. What is 600 minus 400? What's the scale? 200 units, right? 200 by 10, because 10 divisions. Now don't get confused. By 2, by 10. This is graph paper. Number of divisions is 10. Divide by 10. We're trying to understand the value associated with every subdivision on the graph paper. The scale is 200. 1 centimeter is 200 units. By 10 always. 200 by 10. 20. So you're going to skip count in 20s. 400. 420. 440. 460. 480. 500. 520. 540. 560. 580. 600. The scale divided by 10. 200 by 10. 20. 400. This is 420. This is 440. 460. 480. 500. 520. 540. 560. 580. 600. So 580, which is 580? This one is 580. This one is 580. This one is 580. You should read that very carefully. So graph, you must always aim for doing it correctly in the first go itself. Because if you have to erase it, when it's not a graph, you can just strike it out and work it again. But graph is time consuming, right? You need to present it neatly. You cannot erase because then the lines also will almost disappear depending on how hard you rub. The harder you rub, the lines will be so faint that you will not see the green lines. Then you cannot make the graph. So aim for not doing any corrections. Do it perfect in the first go itself. Take some time to read the question, see what changes have to be done, and present the graph neatly in the first go itself. Otherwise, you'll have to again read and the subdivisions, you will have to shrink your eyes and see the 2, 4, 6, 8, path mark funny, height of the rectangle, it is time consuming. So don't do that mistake. Practice well at home so that you do it correctly. This is a sure question. Histogram of frequency polygon, sure question. One of it will definitely come. So tell me, how are the class intervals here? They're not continuous. Yeah, the class intervals are not continuous. So how do we make them continuous? 30 minus 29, 1 by 2, 0.5. Very good. So that's how you construct the new class intervals. Now they are continuous. Put up the histogram. Along the x-axis, these numbers. You can see these numbers. Y-axis. Okay. So that's about the different types of distributions we have in histogram. Okay, I'll talk about this later. Construction of a histogram of a continuous grouped frequency distribution. Grouped meaning there are class intervals and continuous class intervals. Grouped is there are class intervals, continuous class intervals. Continuous grouped frequency distribution, that is, grouped is there are class intervals, continuous class intervals, but unequal class intervals. The class intervals are unequal, meaning the sizes are unequal sizes with unequal, not class interval, sizes, with unequal sizes or unequal bits. Midpoints of the class intervals are given. Okay, and then class intervals are not continuous. So when they're not continuous, they're said to be in the inclusive form. When they're continuous, they're said to be in the exclusive form. Exclusive is when the class intervals are continuous. Inclusive is when the class intervals are not continuous. It's another way of referring to class intervals which are not continuous. Class intervals of inclusive form, they're not continuous. Class intervals of exclusive form, they are continuous. Right? So frequency distribution, continuous class intervals, uniform class size. Just put up the histogram like this. This question was to explain the kink. Continuous class intervals. The class width is not the same everywhere. Class width is not the same. Somewhere it is 5, it's 10, it's 20. So we need to create that new column with the heading adjusted frequency. Use the formula to find the adjusted frequencies. The terms here are actual class size, desired class size. The desired class size is the smallest of all the class sizes. What are the different sizes we have here? 5, 10, 20. The smallest is 5. So your desired class size should be 5. Formula, desired class size by actual class size into the frequency. Will give you the new frequencies. And you need to put up the histogram using the new frequencies. These new frequencies. These are the heights of the rectangles. Ignore these. Similar. You should find out the class intervals. 160 minus 150, 10. By 2, 5. To this number, subtract 5. You will get the lower limit. To the same number, add 5. You will get the upper limit of this class interval. To this number, subtract 5. You will get the lower limit. To the same number, add 5. You will get the upper limit. Then once you prepare the class intervals, you can put up the histogram. Not continuous. You have to make them continuous. 15 minus 14, 1. By 2, 0.5. To the lower limits, subtract 0.5. To the upper limits, add 0.5. When you do that, the class intervals will look like this. And here you can read and check they're continuous. 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5. So the class intervals are now continuous through the histogram. So we have taken up every type that you can possibly get from histogram. We've taken up all the types. All right. There's nothing beyond this. So next is frequency polygon. I'll just come back. Okay, so what still remains to be discussed is how to prepare a frequency polygon, and also two things: how to prepare a frequency polygon independently, and also to prepare a frequency polygon with the help of a histogram. You can make a histogram separately, frequency polygon also separately. You can also prepare a frequency polygon with the help of a histogram. Okay. How to prepare a histogram? We saw the different tables and what adjustments have to be made to prepare the histogram. To what adjustments have to be made in the table before we prepare the histogram. Okay. Similarly, we learn how to make a frequency polygon. So there's also one more thing, to prepare a frequency polygon with the help of a histogram. All right. Okay. I don't think that third part can be covered in the class today. So we'll do that in the next class. So here also, you can see this one is a grouped frequency distribution because there are class intervals and the class intervals are continuous. The width is the same everywhere. 10, 10. The width is 10 everywhere. The class size is 10. Now, to make a frequency polygon, you need to find the class marks, which are the midpoints or the mid values of the class intervals. Simply add 40 plus 50, 90. 90 by 2, 45. 50 plus 60, 110. 110 by 2, 55. 60 plus 70, 130. 130 by 2, 65. See, once you generate first 2 or 3 values, you can just write the others without even calculating, because 45, 55, 65. So 75, 85, 95, 105. Even if you calculate, you should get the same value. So like 120 plus 130, 250. 250 by 2, 125. Okay. So to make a frequency polygon, you need to generate this column with the heading class mark. Lower limit plus upper limit divided by 2 will give you the class mark. Lower limit plus the upper limit divided by 2 will give you the class mark for that class interval. So find the class marks and you have the frequencies. Now, one other thing you'll have to do here is you'll have to take up 2 imaginary class intervals. Okay, which is not needed for histogram. Histogram you don't need. For a frequency polygon, you need to consider 2 extra class intervals, which are not given in the question. You need to take up 2 extra class intervals. One before the first one and one after the last one. To prepare a frequency polygon, you need to take 2 additional class intervals, which are not given in the question. One before the first one and the other after the last one. With frequency 0. You can't assign any frequency, no? அந்த மாதிரி ஒரு கிளாஸ் இன்டர்வலே இல்ல அப்படின்னா frequency is 0. 50 to 60. அப்ப அதுக்கு முன்னாடி என்ன வரும்? 40 to 50. 110 to 120. அதுக்கப்புறம் 120 to 130. Frequency is 0. See here. Frequency is 0. This is the class mark. Don't put 0 here. The class mark is not 0. Class mark is 40 plus 50, 90 by 2, 45. Frequency is 0. Frequency is 0. Frequency is 0. Correct? This one and this one, new class intervals with frequency 0. Then these are the class marks. Upper limit plus lower limit divided by 2. In the points plot pannu. You need to plot 45, 0, 55, 12, 65, 16, 75, 25. You need to plot class mark, frequency. class mark, comma, frequency, not the other way around. Not frequency, comma, class mark. Class marks along the x-axis. Frequency is always along the y-axis. Even in histogram, frequency is along the y-axis. So here class mark, no? So class marks along the x-axis, frequency is along the y-axis. You will have to plot class mark, comma, frequency. So like 95, comma, 32, 105, comma, 27. All the other things remain the same, children. How to write that kink, all that remains the same. You need to show these numbers on the x-axis. All these numbers it should show on the x-axis. All the class marks, no, you must show along the x-axis. And you know when to show a kink. Suddenly from 0, you're jumping to 45. So kink. 0 to 45. And then 55, 65, 75, 85. So when you're jumping, show the kink, show the broken line. Then all these values along the x-axis. All those values are on x-axis. Y-axis, you decide on a scale. அதே மாதிரி தான் ஸ்கேல் எப்படி டிசைட் பண்ணணும்னா சேம் கன்சிடரேஷன். இதை விட்டுருங்க, இது நான் ஒரு புக்ல ஸ்னிப் பண்ணி வச்சிருக்கேன். Don't get confused. So look at the values here. I think the highest value is 32. And you can see some multiples of 4, no? 12, 16, 20, 32. நிறைய multiples of 4 இருக்கு. So you can take 4, 8, 12, 16 here. If I were to prepare, I'll take 4, 8, 12, 16. This is from a book. I've just snipped from the book. So ignore this. So you can take 4, 8, because you can see many multiples of 4, 4, 4, 4. Oh, so many multiples of 4. So 4, 8, 12, 16, 20, 24, correct? You can even take 5, 10, 15, 20. You should read the values. 16, when you take 5, 10, 15, 20, you should read 16 correctly. The line after 15 is not 16. And then plot the values. 45, comma 0 here. 55, comma 12. 65, comma 16. 75, comma 25. So like this, plot the values and join using a scale because it's a polygon. There are two things: frequency curve, frequency polygon. Frequency curve was a part of 10th standard, removed from the syllabus now. Now this is a frequency polygon. Frequency polygon. Polygon meaning closed figure made up of line segments. What's a polygon? It's a closed figure made up of line segments. So you should the free handle scale வச்சு join connect பண்ணணும். Consecutive points connect பண்ணிட்டே வரணும். You cannot join anything. இங்க இருந்து இப்படிலாம் இது ஜாயின் பண்ணி அப்புறம் இங்க வந்து அப்படிலாம் zigzag-லாம் பண்ணக்கூடாது. Consecutive points join பண்ணணும். So this part இதுக்கப்புறம் இது. Then next this. So you get a polygon and this one is a frequency polygon. You can see it is closed with a polygon is a closed figure. You can see this one is closed with respect to the x-axis. That is why we take these two imaginary class intervals. What if we didn't take this one and this one? Then we wouldn't have marked this point 45, comma 0. We would have marked this one first, 55, comma 12, this one first. And then we would have finished here, 115, comma 18, 115, comma 18. Then can you see? The so-called polygon is hanging in the air. Your so-called polygon is hanging in the air. How is it a polygon? It's open, no? It's like this. Something like this. It's open. Then how do you call this a polygon? That is why, that is the importance of taking these two imaginary class intervals. Only when you consider these two imaginary class intervals, you will get to mark this point 45, comma 0 and 125, comma 0, which will be marked on the x-axis, due to which this, the entire graph will be closed with respect to the x-axis. If you don't take this, you cannot do that and then join this and this and say that's my frequency polygon. No. Is it fine? So if it's not continuous. Okay, now the major difference is when we make a histogram, we make use of the class intervals. But when we prepare a frequency polygon, we are not using the class intervals. Upper limit plus lower limit by 2. We are finding the class marks and we're using the class mark. Okay. Okay. So histogram, we use the class intervals. But for frequency polygon, upper limit plus lower limit by 2. We use this formula and we find the class marks. We find the class marks. We are not using the class intervals. You don't have to. So if you were to make a histogram for this data, you'll have to make the class intervals continuous. Here you don't have to make the class intervals continuous because when you find the class mark, without making the class intervals continuous, and after making the class intervals continuous, you will see that the class mark is the same. These are the class marks. Okay. Upper limit plus lower limit by 2. Okay. Now here, the class intervals are not continuous. So we understood when we learned about the histogram that the class intervals have to be made continuous. Now you check, you find the class marks without making the class intervals continuous and after making them continuous. The class mark will be the same. We just try for the first one alone, okay? So the class mark will be 30 plus 34, 64 by 2, 32. Now let me make it continuous. So I'll have to subtract 0.5, 29.5 and add 0.5, 34.5. So now what is 34.5 plus 29.5? 0, 1 carried over, 14, 1 carried over, 6. Same sum 64 we are getting. The sum is the same. Upper limit plus lower limit is the same 64. 30 plus 34 is 64. 29.5 plus 34.5 is also 64 because you're adding 0.5, subtracting 0.5. So the sum will not change. So since you're getting the same total, by 2 we'll get the same class mark. So you don't have to spend that extra time making the class intervals continuous. But again, if your teacher says you have to make it continuous, you have to. But it's not needed. That's not going to affect your graph. Right? Is that fine? So, yeah, not to forget the imaginary class intervals. Don't forget them. Don't forget the imaginary class intervals. So here it will be 30 to 34. So you should understand that why 25 to 29, I'm not explaining. Why 60 to 64, I'm not explaining. You understand why it should be like that. I'll ask you in the next class. Frequency is 0. These are the class marks. And you should plot 27, 0, 32, 12, 37, 16, and so on. So when you plot, you get a graph like this. All right. So I'll be sharing all these images on WhatsApp. Now, don't go with the same scale you see here. We have now understood how to decide the scale. So you go by that. Don't just look at this and mark clumsily 1, 2, 3, 4, 5 like this. All right. So we've discussed histogram and frequency polygon today. We have one more thing to discuss, which is making a frequency polygon using a histogram. That is still to be discussed. Actually, I have another meeting after this, which is why I'm binding up. Otherwise, I have taken 10 minutes and finished that. I think. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you.